6.8 Program Designing. Already we have understood that there are three crucial aspects. One is program designing, second one is program coding, third one is program compilation and execution. These are the three crucial, of course, other steps also there. These are the crucial aspects of the programming, and out of all the three, program designing is the first one. Let us study in detail, because program designing is totally human activity. Human activity, it is, computer has no role at all. It is understanding the problem. Basically, you have to understand the problem meticulously. It is like understanding question before answering. So, if you understand the problem thoroughly, and that means you are understanding what are the activities involved in the program, that is very much required. Because if you take an example, hotel and hospital, understanding hotel domain is much easier than understanding hospital domain. Then there are thousands of domains. Every domain is having its unique features. So all those are, you just have the knowledge of developing software program, but understanding domain is not so easy, because it's not a part of your education. So you should have that type of adaptability to understand any type of domain. Here common sense plays a vital role. Then if you are able to understand overall activities and all the allied issues relating to the domain, then you can design the things properly. So here there are three crucial questions. The first one is, what type of input we have to supply to the program? That is the first question. What type of input values, input data we have to give it to the program? The second one is, what output, what type of reports the client is expecting exactly from the program? That is the second aspect. Third, that is one way, inputs and outputs. Then how to achieve this? How to transform these inputs as this output? That is the thing. And how can we achieve that? And in achieving this task, what are the constraints and how to overcome them? These are the issues. Three crucial questions we have to consider and find out the answer. Simply, which inputs we have to give, which outputs we are expecting. In deriving output, what type of problems we have to face, how to solve them. If you find out answers for these three questions, after understanding the problem domain only, you can think it out, and then that is the basic part of designing. Thereafter, the second step is logical sequencing. Logical sequencing. Logical sequencing means, for solving every problem, several alternative logics may be available. For reaching your home, several ways might be there. A simple example I tell you, very simple example. Now, you have to find out the number of pages in this book. Then counting is one way. Other one is, take the weight of the book. Take the weight of the book. Take the weight of each page. Weight of each page means each sheet, 2 pages, and divide total weight of the book by total weight of 2 pages sheet. Then by that also you can learn number of pages and find the width of the book, find the width of each sheet and divide. So for a simple thing, you are able to find three logics, three alternative ways of solving. So whenever a problem is there with you, then to find out solution, you can have alternative ways. Out of the alternative ways, you have to choose the right one, right logical approach, strategy you have to choose, and that is very crucial. Depending on uh, the logic you have chosen, the sequence of statements are deferred. So always your logic should be simple and understandable. It should not be complicated one that you have to understand. That is the second issue. Third one is modular approach. When you take up a big task, then always you have to analyze. Suppose task is so big, you have to analyze and dissect into subtask, each identifiable subtask. In order to achieve a big task, if you are able to analyze and develop subtasks, you can develop a module for everything. Every module achieves a subtask. All subtasks are properly achieved, ultimately your main task is achieved. So that is called after analysis, you can find out what are the subtasks involved in this. For each subtask, you develop a module. Then that approach is called modular approach. Because of the modular approach, every module is like a independent program. It performs an identifiable task. So in testing, debugging, your job will be done faster, and the program is quite readable. Your strategy is easily understandable. So third one is modular approach. That is very much required, and then you can test the program, debug the program very easily. Testing also will be very easy. The strategy is very simple. Suppose tasks are like this: A, B, C, D, E, F. Your program consists of F tasks, 6 tasks. Each module, this is for each subtask, you develop a module. Then test A module is working properly, B module working properly, C module working properly. Like that, every module you independently test with a reference to its subtask. Every module is working accurately. Then ultimately, after integration of all modules, your program should work properly. That is a simple approach. So debugging and program testing will be easy by modular approach and improves the readability of your code. Now, algorithm development. Algorithm means you are developing your strategy, how to implement you are listing out all the steps involved in the implementation of the thing. For this purpose, two alternative approaches are there. One is pseudocode. Second one is flowchart. Pseudocode means the strategy, the steps involved in that. In a human language, you write all the steps involved in implementation of the program. That is called pseudocode. The same thing can be developed by a flowchart. Flowchart means for every activity, for representing every type of activity, one diagram is there, one symbol is there. So this one you present in a pictorial manner. So that is called flowchart. In a approach, by developing algorithm or flowchart, you can get 100% control over the strategy. Otherwise, before you got a piece of idea, in this manner I have to achieve. When you list out all these things by pseudocode or flowchart, at every point you can have uh, main focus, and if there are any loopholes in your strategy, you can easily find out and plug them. So that's why algorithm development is very crucial, very crucial. And thereafter, we have to, after developing algorithm, we have to write program. And when you write a program, you have to choose the right control structures. Actually, as I explained earlier, uh, let us take the C language or other languages also. They provide wonderful control structures. Those are sequential, selection, iteration. Three types of control structures are there: sequential, selection, and iteration. Sequential means you implement all the things in a sequential order. Suppose you read the book, how you read, line by line you read, and thereafter page by page you read. That is the sequential approach. Now selection. Selection. Suppose you have to find out the telephone number of Ramesh K in a telephone directory. Now you never follow sequential approach. Then you follow selective. What is the selection approach? You find top index ROM and somewhere you find and then you sequentially search for the name you get. That is selection approach. Iteration. The two approaches are not suitable. Some other cases. Suppose you have to pour 10 liters of milk. You have 1 liter mug. What you do? The same action you are repeating 10 times. That is iteration. Other one, you have to learn by heart a poem. Then what you do? You recite it. How many times you recite? Until you memorize it. N number of times you recite it. So there are three approaches in implementation of job, and languages, all languages provide three types of control structures. We have to choose the right control structure. By choosing the right control structure, then program is efficient and as well as it is readable.